So, what is the sky made of, you ask? Well, it's made of lasagna. Essentially, it's a bunch of different layers that have a bunch of scientific names that we really don't care about. We don't need to know this to tell us why the sky is blue. The most important thing that you need to know is that there's multiple different layers of the sky. We have the troposphere, which is the one we live in, the stratosphere, the mesosphere, the thermosphere, and the exosphere. And so I hope you like my little diagram of my arrow that goes up to the sun. So basically, as you follow the arrow along, it gets closer to space. So we live in the troposphere, and then as you go up and up and up, you get higher and higher and higher into different layers of outer space. So in a gist, we're going to start calling the sky a sky lasagna, okay? So we bake lasagna with a bunch of different ingredients, and we're going to call this the sky lasagna ingredients. And so what makes up the air is 78% nitrogen, 21% oxygen, and then 1% of like carbon dioxide, water, argon, helium, ozone, methane, etc., etc., etc. What's the deal here? We've got all the ingredients of the sky lasagna. How are we going to cook it? And so it's cooked in the sun daily and using gravity as a thickening agent. So when we go back to this, we can see that gravity is kind of holding all of these layers of the sky, or our sky lasagna, together. And so it's cooking in the sun every day, and that's what's going to give us our light. And so as TriStars in the chat saying, we also talked about this earlier actually. What was the topic that we discussed on with wavelength? I don't remember, but I've used this diagram before. And so we can see that visible light is a spectrum. The red lights are longer waves and the purple lights are shorter waves. And so basically our sky lasagna is blue because it acts as a light prism. So the sun shoots in light into our sky lasagna, it bakes it, and when we see it, it scatters all this light. And so basically a prism, what it does is it takes one singular light, or like white light essentially, and when you shine white light through it, it breaks it up into all of its different components: red, orange, yellow, green, blue, violet. It's essentially the colors of the rainbow. And so what the sky is doing is acting like this prism. So that's why I've called this prism here, or the triangle, lasagna. And so when the sun shines through this prism, it's breaking it up into multiple different layers of its light. And so what does our sky lasagna do? It only lets some of that light pass through, and it scatters the blue light, which is what TriStars in the chat has been saying. So basically, when we look up into the sky and we see the sun, it's all coming down as reds, oranges, yellows. It's coming directly into our eyes. It's not really getting scattered by the particles in the air, the ingredients of our sky lasagna. And so when I say here that we've got 78% nitrogen, 21% oxygen, 1% of this, all of these ingredients are actually taking this visible light here, and depending on the wavelength, so the longer wavelengths are able to get through these visible lights a lot easier than the smaller wavelengths, because essentially it's moving a lot faster and able to hit these particles which scatter it into multiple different directions. So as multiple larger light waves get through, the sun then appears to us in the colors of red, orange, and yellow, and then the blues and the purples all get scattered a lot in our atmosphere. And kind of one separate subject about this is why the atmosphere is super useful to us, because then the ultraviolet rays, the X-rays, and the gamma rays, which are pretty dangerous to us, especially at levels of the sun, this atmosphere is actually blocking that from reaching our skin, and it's not cooking us. It's not frying us like chicken. So we need to be very thankful that we have the sky lasagna to protect us from all of the dangerous rays and to give us beautiful colors in our sky. But what happens if we lose our sky lasagna, or atmosphere, you say? Well, is our Earth just going to instantly burn up and we're just going to look like Mars? And the answer is kind of. There's going to be a lot of stuff that happens. So like I said earlier, we've got this section of rays that won't be blocked by our atmosphere. And so when we lose the sky lasagna, basically all the gamma rays, the X-rays, and the ultraviolet rays are just going to laser beam onto the Earth and start to really do a lot of damage. And so some of the common problems that we get from these UV rays, these gamma rays, and these X-rays that come through is we really get cancer, sunburn, and skin diseases. And also in the hot summer, like you see this on the moon, which doesn't have that much of an atmosphere, the hot days can get up to 253 degrees Fahrenheit. I don't know the Celsius conversion rate for some of those people who aren't American, because we Americans are weird and use the Fahrenheit system. And the opposite of that, in the night when you don't have the sun baking you, there's no atmosphere, there's no sky lasagna to hold in that heat. So all that heat goes up into space, and we're down to negative 243 degrees Fahrenheit. And so humans can't survive in that without any exoskeleton or anything outside of them to protect them. And also another thing is there's no air for sound to vibrate through. So everything on Earth is going to be completely silent, just like it is in space, because there's no air for any sound to vibrate through. But really, this isn't the worst of our issues. Without our sky lasagna, the oceans are going to boil and freeze. And this is because our atmosphere, here I have 0 ATM means 0 atmosphere, and it can be used as a measurement of pressure. And so at 0 atmosphere, water can only exist in 2 phases. It can only exist as a solid or a vapor. So once our atmosphere disappears, once we have no sky lasagna protecting us, the pressure on Earth just completely goes away. And so our oceans are going to instantly start to boil, and they're going to start to freeze at like the exact same time, which sounds super weird, but at 0 ATM, it literally cannot exist as a liquid. It is just not physically possible. There's no way that you can make water at 0 ATM a liquid. And then another big thing is that the asteroids are going to have no friction from our sky lasagna to burn them up. The asteroids are going to have no barrier to get through before it hits Earth. We're going to start looking like the moon with a bunch of asteroid craters. And so basically humans will not be able to survive. There's no way that humans will be able to survive without our sky lasagna. It's just not possible. So we really need to do everything we can to protect the sky lasagna that we have. Because without it, we're not going to have water. We're not going to be protected from UV, gamma rays, X-rays. We're going to really have cancer problems. And these asteroids are just going to destroy us. Without any extra protection, like a dome over us, providing us protection from the sun, acting as a fake sky lasagna, we're not going to survive. All life on Earth needs oxygen. And so without our sky lasagna, the biggest thing is there's no oxygen. Everybody is going to die. The oxygen is just going to disappear because it's just either going to go up into space or it's just not going to be there, because oxygen makes up a huge part of our atmosphere, and it's what we need to survive. So trees aren't going to be able to survive. We won't be able to survive. So without sky lasagna, everyone dies. And we need the protection that sky lasagna offers us. And I know this is kind of a funny science topic and a kind of a funny comparison. It's not a perfect comparison, but sky lasagna and sky atmosphere, it just works so well in my head in terms of the layers and how I could use it to describe it. And so almost everyone likes lasagna unless you're lactose intolerant, which I feel so sorry for you. But sky lasagna is amazing, just like our atmosphere, and we need its protection. So we need to make sure that we're doing what we can to protect our atmosphere, the ozone layer. It's all very, very important.